Hello, welcome to our educational technology topic this week, which is computational thinking and gaming in education. So, what is computational thinking? It's basically a problem-solving process involving four key techniques. The first is breaking down complex problems into smaller parts or decomposition. Second, finding similarities or pattern recognition between different things in the problems. Third, focusing on the essential details or abstraction. And fourth, creating step-by-step solutions to be executed by people or by machines, which is algorithms. One example that I like for this is if you're planning a trip somewhere and you need to be there at a specific time, especially a longer trip. You start by figuring out when you need to be there. You want to figure out the time it's going to take you to get there, and then build in a safety margin, for example, so that if there's construction on the road or if it takes longer to get a meal partway through the journey, that you have time to get there so you don't arrive late. So why would we bother engaging learners, especially in K-12, in the basics of coding and computational thinking? Well, first off, it's a cognitive tool set that's applicable to any field, as diverse as from literature, structures in literature, to optimizing supply chain and business. And it provides a framework to tackle really big problems, breaking things down, isolating variables, and then a step-by-step process to figure out potential solutions to a problem can be really helpful, not just in school, but throughout life. There's some really helpful resources for computational thinking. Even in School District 61 here in Victoria, BC, they have a learning hub for coding that is quite helpful, coding and computational thinking. So this is a video that goes through a process. A dad asks their kids how to make peanut butter and jam sandwiches. And it's quite funny, but it shows how if you don't give specific instructions or detailed instructions of exactly what you want someone, or especially something, things can go awry. And this is particularly important in coding, and especially in vibe coding, where you're giving a prompt to a generative AI tool. You need to make sure it's specific so that it'll do exactly what you want it to do. Here's just a little bit of the video here.
You're not making any sense. He's already ruined it on purpose. He knows how to make one.
What's up, the internet? You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich.
Okay.
Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out of the...
That means like a lot.
A bit means a lot?
In my world.
Spread your scoop of peanut butter onto 1 of your pieces of bread with a knife. All right? There we go.
You're doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
Nope.
Done. Closer.
You suck.
So you can see that the dad is doing exactly what the kids asked him, and that is a lot like the coding process, where one small detail that you missed or maybe don't describe 100% correctly can lead to a program doing something very different than what you hoped it would do or what you intended for it to do. So here's an example from my family. A number of years ago, my daughter wanted to adopt some fainting miniature goats. And but in order to have a home for them, we were repurposing, as you can see here, a kid's playhouse, but needed to build a ramp for it. And it's important to know that because of the ramp, we needed to do some fairly complicated math to calculate the slope of the ramp that would make it so that the goats would be able to climb up it without any problems, but also so that the length of the lumber wouldn't be too long so that we could bring it home from the hardware store in our Prius. So I had to dig deep into the cobwebs of my memory, and I recalled a field trip that I went on when I think I was in about grade 5, where we had to calculate the height of a tree using a tape measure and a protractor. And I found this image on the internet, and I couldn't remember what math we used, but it was the tan function in particular that we used. We measured from the base of the tree to where we were standing, and then we were in pairs, and we would get a protractor measurement of the angle, and then we'd use the tan function to calculate the height of the tree. Must have been sponsored by the Forestry Association or something like that, because I think we also calculated the amount of lumber in the tree based on the circumference and height of the tree. But anyways, so we had to do some fairly complicated math. And while not excited about the math, my daughter was excited about building a ramp for her goat's new home. So we worked through this problem together, and she eagerly learned how to use trigonometry to make sure that the ramp wouldn't be too steep. And again, like I mentioned before, to make sure that the lumber would be short enough to fit on the roof rack of our Prius. And it was a big win for everyone involved and helped her learn some advanced math as a byproduct. As you can see here, we ended up doing a 2-tier ramp just so that the ramp wasn't going to take up the whole yard and be in a little bit more confined space. But and it worked out really well. She was happy with the goats. That was Gabby there and Baby, and our lab Maggie wondering what the heck is going on with these smelly little animals. Back in 2023, just for fun, I asked ChatGPT for directions on how to build a ramp for a goat, and I looked at them and go, oh yeah, they've got the lumber there, although I don't think there's quite enough. And then I looked through the instructions, and basically it wasn't building something long enough to be a ramp. It was building something 5 feet long, which is a wall, not a ramp. So these are terrible instructions. So yesterday I tried it again to see if it would do a better job, and actually it looks better. I do need to do the math to make sure that the 12-foot long ramp actually would give a 25 to 35% slope. Although in other things that I Googled just now, it looks like recommended is like 20% slope, 20 to maximum 25. So that might be a little bit off. Anyways, improving, but probably not quite there yet. Actually, I should change that from pretty good to maybe pretty good. So we'll just again, talk a little bit about computational thinking through coding. There are some great tutorials, free tutorials. This is from the Hour of Code, and there's another excellent website put out by the MIT education folks called Scratch that has a bunch of interesting games. But this is learning to do some basic coding and computational thinking using some Anna and Elsa skating, making geometric shapes. Let me just get it open here. So for example, if I want so I'll reset it. Want her to move forward, I just drag and drop here, and then I press the run button, and she will move forward exactly what you tell it to do. Next thing I'll do, I'll put that, and then I'll maybe have her turn right, move forward 100 pixels, turn left. Actually, I'll have it turn right. This time I'll change it to 45 degrees just for fun, and then move forward. And let's see what happens. So you give the instructions, you have them. And there we go. We got a interesting or somewhat interesting shape. And again, this is a multi-step lesson that will walk through your students. I think they start with a square and then move to increasingly complex shapes using different programming techniques like loops, variables, conditional loops, things like that. And there's a number of games that I've got that you can play with, and I'll put these in the show notes, that teach different skills using games that may or may not be interesting to your students depending on their interest. But this is an example here. You can see there's a loop here, and then with a conditional loop, and again, this is just moving and changing direction and moving again. But again, this is step 5 of 18 or so steps. So vibe coding is something that is relatively new in the past year, and it's becoming increasingly common for people who are computer programmers or coders as well as non-coders. If you haven't heard of what it is, basically you give the generative AI tool that's built for coding your creative intent, what you want it to do, in some detail, like the PB&J video. You need to tell it exactly what you want because it can't read your mind. And then it will build it typically quite quickly, and then you can test it, see if it actually did what you want. If it didn't, you can give it another prompt to maybe fix what it didn't get right, or maybe extend it because it got what you did right and you want to add on to it. And it's quite powerful, and it's, again, if you've got computational thinking background or some experience with it, it's actually hugely helpful, especially in coding and vibe coding. So this is an example from just 3 weeks ago. One of my former students in IED 336, or Indigenous Education, EdTech for Indigenous Education, she emailed me asking if I knew of any web-based tools like H5P that would allow them to create a soundboard for their nation's alphabet. So it's buttons that you click on. And I told her that I looked through H5P, and she had also looked, but I double-checked, and there weren't any H5P tools that would do this. So I emailed her back saying there aren't any tools in H5P, but I'd been looking for a vibe code project to do, and this looks like something that might be doable with vibe coding. So let me know if you'd like me to give it a try, and I'm happy to give it a shot for you. And this is the prompt that I gave the vibe code tool. And I also, she gave me a soundboard that a neighboring First Nation had created, hired someone to code for them. So I gave them that as an example of what I wanted. And in 5 minutes, less than 5 minutes, it created a soundboard, a very good one. I use the Brazilian alphabet because I speak Portuguese somewhat fluently, and it was something I could fact check in real time, and it did an amazing job. Like I said, this took less than 5 minutes. Now, when you click on the letters, there was no sound because it couldn't generate the sound. So I spent about a half hour recording the alphabet, and then with those, it was able to create a functioning soundboard where you click on the letter, and it plays the sound. I'll just show you this real quick here. So if I click on A, or Z, Aga, E. Anyways, you can get a sense for what it does. Again, this is probably 35 minutes. Less than 5 minutes of it was the coding part. Yeah, pretty amazing. And it will work on a phone as well. It'll resize the phone. You've got to scroll to click on the letters there. In addition, I wanted to create a game that would be one step beyond the soundboard. So I remembered this Math Blaster game that my kids played when I was younger. It's pretty simple. In the Math Blaster, you'd have an equation coming down, and then you'd type in the solution. It was just basic, addition, subtraction, multiplication, division, and then getting increasingly fast. So I thought, well, if I have the images that they have associated with the Koala language alphabet, they could see the abalone shell and then click on the letter associated, which was an I in that case, or and so on. So again, I made this yesterday afternoon, and it took me about 20 to 30 minutes to get to this point. It's not finished, but it is, it's actually functional now, and based on feedback from the language revitalization teacher, we'll change it and improve it. I'm not sure if they'll like this metaphor of, shooting the objects, but we'll figure something out that will work for them. But this is a prototype that, again, took 20 to 30 minutes to create, which is pretty amazing from my perspective. So, as we talked about in our Generative AI Week a few weeks ago, there are significant environmental considerations for these tools. So looking at vibe coding in particular, what is the environmental impact? Especially compared to if I was to code a game like that on my own. Putting aside the constraint that I just don't have time to code them, so I probably wouldn't attempt it, but let's say that I was hired by someone to code the soundboard, for example. That would probably take me like a half a day, so maybe 4 hours. Actually, it's been a while since I've done a lot of coding, so let's say 4 hours, we'll be generous. So I'm going to be working on my computer, uploading things to a web server, testing for probably 4 hours. I have not tried to run the numbers, but I'm confident that the energy use for the less than 5 minutes for Claude code or Claude to generate that code would be less than me running my laptop for 4 hours and working to generate the code by hand. But there is the time and the cost consideration as well. Just personally, as a teacher, do you have the time to create a custom game that's localized to the needs of your students? Especially in your first few years of school, probably not. But if you could create something in 5 or 10 minutes, that might be doable for you. And again, it's a custom game specific for your class, or maybe just individuals in your class that are struggling with something or want to explore something further, and a little educational game might be helpful. So, games in school. Something just to think about. What types of non-electronic games have you seen played in school, either personally or in other classrooms? And think about maybe electronic games or computer-based games. What sorts of games have you seen? And maybe what excites you and what concerns you about introducing games as a teaching strategy? Is there... could you go overboard with games? The screen time is another big issue. Getting people outside. Maybe it's a non-computer game outside. That might be a more appropriate thing to get your learners away from screens and in the fresh air for a bit, just as one example. Now, there are different types of educational games, and this is from an article that I'll show you in a minute. There's gamified learning activities, and an example of that is Duolingo, where you've got leaderboards, you've got points for doing specific learning tasks in the game, and badging in general. So it's not really a game, but you're gamifying learning activities, which can be effective for some people, not everyone, but it's a type of creating an educational game. And Duolingo is the one that I know best because I use it to brush up on my Portuguese and Spanish speaking. Another one is single-player digital games, things like Math Blaster or the game that I just showed you that I created in about 20 to 30 minutes. Another one is Bad News. to help people learn about disinformation in the news. And again, I will encourage you to play this in a minute, a few minutes. Oregon Trail is another educational game that goes back to the 80s. And Pandemic is a really interesting one that I saw my son playing. This was pre-COVID. It's just a web-based game, and it looked intriguing, so I actually looked it up, and it's actually grounded mainly in good research about epidemiology and how disease spreads. And I assumed that my son playing the game was trying to save the world from disease. As it turns out, it's the exact opposite. You're trying to create a virus or a disease of some kind that will spread, and you learn a lot about communicability of diseases. And yeah, it's actually quite interesting. It's a little different world we're living in now, pre or post COVID, but it's a great example of a compelling game that really teaches you, because of the gameplay and the game mechanics, about communicable diseases. Even though maybe the topic isn't the best one nowadays. So multiplayer games, you can do escape rooms or group simulations. And then active versus immersive games. So most games are going to be active, but a VR simulation could be really effective if created in a compelling way. But just a desktop game like Settlers of Catan can be really compelling as well. It doesn't need to be really complicated to be a compelling educational game. So are educational games effective learning tools? What do you think? Yes, no, depends. Well, it really depends. Just like someone can create a really, really boring game. It happens with educational games as well, of course. From research, some of the things that can help educational games be effective include instructions on explaining underlying concepts at point of need, typically. Include scaffolding and mechanisms for guidance. So if you see someone struggling, give them a little bit of support. If they're not struggling, then you can, let them figure things out more on their own. Offer challenges that are just doable. So you want to be in that sweet spot. You don't want to be too easy that it gets boring. You don't want it too difficult so that people get demotivated and stop playing. It's got to be in that sweet spot. So your game hopefully will calibrate to how the player is performing, to either ramp up the difficulty if they seem to be, nailing everything really quickly, or if they're really struggling, make things easier so that they can not be discouraged and quit the game that way. Dynamic scoring can also be really helpful in providing that feedback in their progress through the game, whether they're going really quickly or not. That feedback, so they know how they're doing, is really something that you'll see in effective educational games as well. And you want to promote learning without time constraints or penalty. People, if they get something wrong, maybe don't reward them for that, but don't, take away points, for example, if you're in a points-based game. Give them positive feedback when they've done something right. Give them feedback that they, how they've done something wrong, and maybe some guidance on how they could do better if they're really struggling in the game, but don't take away points as one example, or don't penalize in different ways. So this is a study from, I think, about 12 years ago now, for teachers in the United States, and it's sort of interesting to look at back at that point in time who used games in terms of grade levels and what types of games. So it looks like grade 3 to 5 teachers in the United States at that point used games the most, when dropping down to the lowest for high schoolers, which is interesting. A lot of games use them for math, history, English language, and science is lower, which is interesting. And then here's some reasons that the teachers who use games indicated why they use them. And 90% believe they are effective for motivating, almost 90% for reinforcement of content previously taught. 2/3 said they provided useful information about student learning, so they could get a sense based on their scores about how they were doing, which is actually a useful tool, and 60% for teaching new content. And some of the barriers they identify would be the cost of games, which vibe coding could potentially could address. Limited time was another issue, and I think that's limited time in the classroom, not limited preparation time for the teacher, but that's obviously an issue. Lack of technology is a big one. That's still going to be an issue if you want to be equitable. So providing tools with kids with the tools they need to play the game is important. You may not have easy access to that in your school. And then another one is unsure of where to find games, which again, vibe coding could be an issue if you've got ideas for games already, of course. Another one, hopefully this isn't as big an issue in British Columbia, but in the States, emphasize on standardized test scores and teaching to the test, which is a big issue. So it's active learning time now. I'll put in the show notes a link to where the hands-on activities are, and I hope you found this this week useful, learning about computational thinking and learning games, and we will see you next week.